So it's talking about satellite telemetry. That's not so much about monitoring, and so I'm going to go fast because you are late. Or it's a bit about monitoring, but not so much on a populational level. Or if you want to do it on a population level, it's far more challenging, and I will explain why. So what we do, we just put, we track individual animals by deploying instruments on them. And those instruments will transmit information to a satellite that will give us positions or other data. So disadvantages is clearly the cost of the tags. They can go between 3,000 to 5,000 euros or more. And the services of satellites, because you also pay for that. There's still there's high rates of uncertainty in the tag deployment and the operational success. What do I mean by this? We need to find the animals. We don't always find them. We need to approach them and deploy the tags successfully. Sometimes they are not in the mood to collaborate with us. Then they can be deployed, they can stay attached, but we still don't know exactly for how long and what might influence the length or the time duration of the tag. If it's badly implanted, we might not get a good signal, then we don't have so many good positions. Or it might be well implanted and sometime 3 days later it falls, or it can last for 3 to 6 months. It varies also. We know more and more as we put tags. It's better with some species and it's worse with others. But again, there are some challenges that combined with the costs are very challenging. There's still room for improvement in technologies, especially on what concerns attaching the tags, because that's one of the major tasks, challenges. There are some species which is easy. You catch a turtle, you just fiberglass the tag to the shell of the animal and you throw it away, and then you just get good results out of it. You can do that with seals, and you just glue to the head of the seal, and they will do it. They will even phone home saying, well, "I'm here." They just do it. So you use GSM coverage on the coast of Scotland, and they phone. They use the network, and they phone, and they give the bunch of information through GSM, mobile phone network. But with cetaceans, implanting the tags is complicated, and keeping them there and avoiding other issues as infections and other problems. So, and then there's another possible problem, which is how to extrapolate from information which is at the individual level to a population level. That means, again, a problem of sample size. We need to put lots of tags to be able to extract a pattern from the movements of the animals. Otherwise, what we have is individual movements. And some of you will definitely know, like radiation movement. So each particle has its own movement that overall you can have a movement understanding of the whole pattern. But with animals is the same. Each one will have its own pattern. And from that, from a few animals, you can't predict or understand what is the general pattern of the population. You need a minimum number of tags, which you still don't know for many species, to actually start getting some pattern out of it. Some might be more clear, like humpbacks migrating. They kind of have clear corridors. But even then, there was a humpback that was migrating from Norway, got to the Caribbean Sea. You expect then will stay there now. Next day, start going back. So there is clearly individual variability, and to use this technique to get to a population level and extrapolating to a population level is quite difficult. There's it's an intrusive method with impact on the animals and requires strict protocols to minimize that impact and risk of infection. You don't want to follow a dead animal, you want to follow a live animal. There's EU legislation limitations, so you need to have a license approved. You need to be a certified and trained person to be able to deploy the tags, and the project needs to be licensed. So it's a long process. It takes sometimes a year or more to get that done. You need extensive training, not only of the person who's deploying, but all the team which is doing that. Because as for photo ID, there's a strict and important relationship between the driver of the boat, the captain, and who is deploying. They should function as one, as a team, so they are successful. Otherwise, you will not be able to deploy The boat might be in the right place, the shooter is not ready. Or the shooter is ready, the animal is ready, but the boat is in the wrong place. So you need to combine several variables. And the other thing is safety, your personal safety, because you use guns, air guns, to deploy the tags, usually, or crossbows, which means are objects or the equipments that can throw objects at high speed. You can get someone hurt, or you can get yourself hurt. Advantages: you can follow animals over a wide area because you use satellite coverage. And for highly migrating, highly mobile animals, this is fantastic. And you can do it for considerable time periods, if you're lucky enough for the tag to long a lot. And from there, you can get positions at regular intervals, and from which you can infer movements, behavior, even using some models, swimming speeds, you can and get to that, all of that into your models. Some tags, the most expensive ones, you can get some information about diving patterns, which you can infer other behaviors which are ecologically relevant. And you can, for some of them, still limited, collect some data, environmental data like temperature, which can be useful. So another advantage, getting the understanding of the movement patterns will help you understand photo ID results. And I'll go back to that. So this is the kind of equipment we have. I have it here, but I don't think we have much time. I don't know if I'm already behind quite a lot. What time is it now?
Just about to do
one.
Yes.
Okay, so I'll go quickly. I can just show you, put it here, we can see it later. This is one of the tags, very small. It's 50 grams, so it's something the animals like the whale can handle it. Yes, you can take it around.
Be careful with the tips.
Yes, they are pointing and they can hurt.
Is it working? We can follow you.
And here what we see is the attachment, the tagging of one animal on the dorsal fin. And it was using an air gun, which shoots at 25 bars, so it's quite a lot. And in this case, we also tried to get biopsies of the animals for stable isotope studies, trophic level studies. Here is another animal. If you look here, it's a good position of the tag, so we got higher quality positions. Here it got lower, so we didn't get so good quality. We still followed the animal so good, and you can see from the side. And now, this is an hypothetical case. The same animal photographed in this place, with 6 days apart or 7 days apart. We can assume that the animal was just moving from there here or being around here. And you could, from photo ID, that's what you get. You get one position, one detection, and the other, and you assume that they might be around here. When you put that together with tagging, it's not true. So the animal was tagged here, just went around, down 60 miles, here, and then came back later to be seen in this position. And then it continued and went up north 100 and something miles, and 3 weeks later was down again. Well, 15 days later was down again. The other one stayed 4 days here, and that just went in 2 days here, and then stayed for almost 2 months here. So photo ID is good. It helps to understand a lot, but you need also this kind of information to be able to interpret better. Of course, we can't get, for now, the same kind of sampling we get from photo ID. We can't get it from tagging for the reason I explained before. And I was going to talk about biologging. Forget it, we don't have time. So and we keep going. We can talk this later. And biopsy. And in this case, it's just to tell you that you can use the genetics, the samples, the skin, for genetic studies, for instance, to understand the structure of population. If you share animals with the Azores and the Canaries, and that happened, and we know we share some populations, and also to understand trophic relationships. So if animals feed at the same trophic level or from the same kind of spray, In this case, we have Brutus whale feeding lower trophic level. We have short fin pilot whale at higher trophic level, closer to sperm whales and Mesoplodensia horsfish, which is plain-billed whales. And then we have the dolphins in a wider, eating from higher trophic levels and lower trophic level species. Okay, and I don't have time to go more into detail about this, and maybe we can take the questions later. Thank you very much.